Hello, my name is Shapsila and welcome to my channel. So today we will learn about the analysis of algorithm. In the previous video, we have learned about the approaches of algorithm. So in case if you didn't see that video, please go check that video and come to this part. Otherwise, you will not be able to understand what I am going to teach you today. So we will learn about the analysis of algorithm. So the algorithm can be analyzed into two levels. That is, first is before creating the algorithm and second is after creating the algorithm. The following are the two parts, or we can say the two analysis of an algorithm. First is priority analysis. Here priority analysis is the theoretical analysis of an algorithm which is done before implementing the algorithm. Various factors can be considered before implementing the algorithm, like processor speed, which has no effect on the implementation part. Second is posterior analysis. Here, posterior analysis is a practical analysis of an algorithm. The practical analysis is achieved by implementing the algorithm using any programming language. This analysis basically evaluates that how much running time and space taken by the algorithm. Then the complexity algorithm, or we can say the complexity of algorithm. The performance of the algorithm can be measured into two factors. First is time complexity and the second is space complexity. So what is time complexity? The time complexity of an algorithm is the amount of time required to complete the execution. The time complexity of an algorithm is denoted by the big O notation. Here, big O notation is the asymptotic notation to represent the time complexity. The time complexity is mainly calculated by counting the number of steps to finish the execution. Let's understand the time complexity through an example. For example, I have written that sum equals to 0 for I equals to 1 to n. Suppose we have to calculate the sum of n numbers. Then sum equals to sum plus I returns sum, which we will understand that when the loop ends, sum holds the value. So in the code, the time complexity of the loop statement will be at least n. And if the value of n increases, then the time complexity also increases. So while the complexity of the code, that is return sum, will be constant as its value is not dependent on the value of n and will provide the result in one step only. We generally consider the burst type complexity as it is the maximum time taken for any given input size. Then the space complexity. An algorithm space complexity is the amount of space required to solve a problem and produce an output. Similarly, to the time complexity, space complexity is also expressed in big O notation. For an algorithm, the space is required for the following purposes: to store program instructions, to store the constant values, to store the variable values, and to track the function calls, jumping statements, etc. So what is auxiliary space? The extra space which is required by the algorithm, which we can say that excluding the input size, is known as auxiliary space. The space complexity considers both the spaces, that is auxiliary space and the space used by the input. So we can say that space complexity is equals to auxiliary space plus input size. So thank you. In the next video, we will learn about the types of algorithm, and that will be the final part. So till then, bye bye.